Hi, everybody. We have another similar review from yesterday. Yesterday, we did sides and diagonals, which were both segments in all four of the shapes you've learned: parallelograms, rectangles, rhombuses, and squares. And today, we're doing the same thing with angles, both angles at the corners and angles that are created with diagonals. Once again, you're going to go to Mastery Manager. It's ExamLogin.com, which is through a program called Mastery Manager on my end. And once again, do a number of questions online, submit it for a grade, and see what you get afterwards the next day. And if you're not happy with your grade the next day, you can always do some work to make it up. Yesterday's was out of 11 questions, but in the gradebook it'll be out of 10. And today's will be 12, and again, it'll be out of 10. And one of the reasons why I'm giving that available for extra credit is just because of a difficulty, not of the topic, but of three-letter naming and doing three-letter naming on your own without having a teacher here to check on what's going on. So, to show you what's going on here, angles at the corners of parallelograms, rhombuses, rectangles, and squares. We have learned the opposite angles are congruent, but differently, the consecutive angles are supplementary. Reminder that supplementary means adds to 180. All right, so just to be careful in what we're talking about here, opposite angles are congruent, like this star is equal to this star, like this heart is equal to this heart. However, the other ones are not congruent. A star is not equal to a heart. They are not the same. Instead, those add to 180 degrees. So there is two options with angles. Unlike yesterday's lesson, which pretty much everything was just equal when it came to segments, it's which things were equal and what things are different in some way, angles have multiple options. One of the options is congruent, like the star and the star, like the heart and the heart. The other option is that they are supplementary and add to 180. We have a third option here, because in all rectangles and squares, all angles are right angles. In other words, all angles equal 90 degrees. Okay, so we have three options, right? Well, even sort of more here then. When you draw on diagonals of parallelograms and rectangles, there are no special properties, but you can subtract one piece of an angle from a whole angle to find the other. For example, if you drew in a diagonal, it doesn't necessarily split the angles equally. It does do that in rhombuses to some degree and squares, but not in rectangles and parallelograms. So, in rhombuses and squares, the diagonals are perpendicular, which means forms 90-degree angles. So there is 90 degrees in rhombuses and squares also in the middle, but as well, they bisect the angles, which means you have equal parts. And these are some of the things you were doing on IXL. We are now doing the same vocabulary with easier problems and easier numbers, but with not every picture looking like every other picture. So we have a lot of different possibilities here. We have, when you have things involving angles, they could just be equal, or you could do 180 minus your number. That little pound symbol there, the little hashtag symbol, means number. Or you could add to 180. Not add 180 with it, but do first part plus second part adds up to a total of 180. Or you could have things just equal to 90. Or you could do just some regular subtraction and subtract a big part minus a small part to get the other small part. And you could combine two of these together and bisect the angles, and when you bisect the angles, you could have a 90-degree angle divided by 2, meaning you could have 45-degree angles. Not everything will be 90. Not everything will use 180. We have a lot of different options here. And that's why reviewing angles can be just a little bit harder than reviewing segments. So we'll go over it here. Still a relatively short video, still a relatively short assignment, only 12 questions coming up. But let's see how these different things apply on pictures. And so here's your examples you probably want to have out when you're doing your problems on ExamLogin.com. If you have a parallelogram, this is not a trick question. What is angle R equal to? And the answer is not 7 or 424. Those are sides. Angle R is just equal to 46. It's that easy. But careful, as a reminder, angle A and angle L are not equal to 46. No, instead you subtract from 180. And that's how you get other angles that aren't equal. Not supposed to be too bad, not supposed to be too hard. Make sure you can trace your letters, and this can be a little bit hard on a screen, so if you need to have paper out when you do your assignments, have paper out. Angle ERT, trace it. ERT. Oh, it traces over the 5 and the 19. So do I add them together and get 24? Nope, it has nothing to do with 5. It has nothing to do with 19. What do you know about this angle right here at corner R? It starts at E, goes to R, and goes to T. Not 5, not 19, not 20, but it's a right angle. It's a 90-degree angle. You've known that fact since you were first learned about angles in grade school. 90 degrees in corners of rectangles, 90 degrees in corners of squares. The only thing that's added in here in high school geometry is being able to name things with 3 letters. That's something that you've been doing since August, but we've sort of dropped it off, picked it up, dropped it off, picked it up. It's now a big thing again. You want to make sure you can handle 3-letter naming. And additionally here, angle ERC. Angle ERC is not the whole green angle of 90. It's not equal to the other part 20. Instead, it's the whole angle of 90 minus 20 gives you a remaining part of 70. So I'm going to pause here for a moment in terms of the writing on this page. To flip back to the previous page here, you can see blue, red, green, yellow. And on the previous page, look at the bottom. Blue, we could set them equal. Red at the bottom, we could subtract from 180. Third one could just be equal to 90. Fourth one, probably should have written in yellow if I'm color coding right. But we're going to subtract the whole angle minus the small angle. Look what we just did here in yellow. The whole angle was 90, minus one of the small pieces was 20, gives us the other small piece, which is 70. So there's lots of different options here. Not everything is done the same. All right. Tracing angle HRS here. We need to color code this to make sure we're set. What is angle HRS? Well, in a rhombus, you have bisecting angles. So in a rhombus and only a rhombus, would it just also be 40? Take a look here between the two problems that we just did. On this problem, both this little part is 40 and the other part is 40. However, on the problem right above it, they aren't both 20 degrees. One part was 20, the other part was 70 because they had to add to 90. In rectangles and rhombuses, you have different things going on with angles. Next thing, how big is angle HMB? Well, here at corner M on this side, we've learned in any type of shape, it's the same as the corner on the other side. How big is this whole corner? Well, 40 and 40 are the two pieces. It's a total of 80 degrees. Not too bad, not too hard. HSR, let me trace it in the picture. HSR. We're talking about this angle in the middle. This angle in the middle we've learned in rhombuses and squares. The diagonals are perpendicular, which means they form 90-degree angles in the middle. Not in rectangles like the picture above. We have obtuse and acute angles in the middle of a rectangle. But in the middle of a rhombus and in the middle of the square at the bottom of the page, we have 90-degree angles in the middle. Next problem, RHS is this little angle right there. How do we do that? Well, we go back to what we learned about triangles. 180 degrees in triangles, minus 90 in the middle, minus 40 here. We did this problem over and over again on IXL level N.8 on Monday, but it's been a while since Monday. This is just a Monday problem, easy Monday problem thrown into this review here. Comes out to be 50. And then how big is RHM, the whole angle? 50 plus 50, twice as big, has to add up to 100 because the diagonals bisect the angles. Not too bad, not too hard. All the hard part of this is going to be is tracing your letters. And if you don't have a screen that you're good with tracing and doing it by fingertip, then you have to maybe use paper and rewrite these problems. Some people can do this in their head. Many people can. Not everybody's a visual learner. When I first started doing these years and years ago with geometry, I was horrible at the visual part. I could figure out the step-by-step processes. I could memorize vocabulary. I did all good with that. The minute I saw an unusual picture, I struggled. So this idea of how I trace, like from S to Q to U, and why I keep emphasizing it is because not everybody processes it right well in their head. Now, I've been teaching this class for 20 years now. I can do these problems in my head, but back when I was a teenager, I couldn't do these problems in my head. I had to literally trace them because everybody's strengths and weaknesses falls in different areas. If you can do these in your head without writing stuff down, great for you. It's a good talent to have, impressive. But if you can't, it doesn't mean you're a weak student. It just means you visually process things differently. So trace when you need to. This color coding can be useful. SQU there, as you can see, is just a 90-degree angle. SQR is half of that 90-degree angle, which is 45. And lastly, SRQ, first S, then R, then Q. We're talking about this angle in the middle. Just like the previous problem, diagonals perpendicular, angles in the middle are 90. So whenever you have a problem involving whenever you have a problem involving a square and its angles, it's going to have to be something with 90 or 45, at least if you're talking about one individual angle. All right, I would keep this video up and be able to either fast forward or rewind to the page that you want to see. Maybe just take a screenshot of this page and have it up as a picture when you're doing it. For some of you, that'd be enough, but use this as a reference. And as you go through the 12 problems on your ExamLogin.com, you're going to see a lot of problems be calculated just like these. It's figuring out which one are they. Like in blue, are things just equal? Like in red, are they consecutive next to each other, like angle P and angle A at the top? And when they're consecutive, like angle P and angle A at the top, like in red, subtract from 180. Do you have 90-degree angles, like corners of rectangles in green, corners of squares in green, the middle of rhombuses in green, the middle of squares? All those are 90. No math to do. Do you have to possibly add or subtract two angles together, like we did in yellow in a couple problems? Be careful about that. There's some methods involved with this. And of course, make sure you feel like you know your vocabulary. If you don't feel comfortable with the words bisect, supplementary, even congruent, have your notes in front of you. Everything at the moment is open note. We can't have you guys memorize things for a test at the moment with distance learning. So have everything in front of you. Go to your 12 problems. Even if you get a 10 out of 12, you're in good shape. They'll go in as 100%. If you get an 11 out of 12 or a 12 out of 12, it'll go in as extra credit. And if you happen to do poorly, you're more than welcome to make it up. You'll just have to do some extra work to get your points higher. Hope this video was helpful. Hope your assignment goes very easy today. If you have any IXLs to catch up on, I would also do that. Because we are moving on to area and perimeter next class, going back to IXL, and doing a bunch of things with that to make sure we're set with how to handle those in all four of these shapes. Area and perimeter is pretty easy at first, but then we're going to have to integrate in Pythagorean theorem. We're going to have to integrate in sine, cosine, tangent problems again. And then lastly, we'll be doing the same algebra that you did on all your IXLs, but doing them with factoring problems, the ones with quadratics, with x squareds in them. So we have some things that get a little bit tougher sooner than later. Make sure you feel comfortable with all four of these shapes pretty well. Contact me with any questions, and good luck. Take care, everyone.